We have to solve for this integral problem here by using the integration by substitution. Knowing that we can utilize this format here, we can look at this format, integral of u prime of x divided by u of x dx. We have the derivative of this function at the numerator of this fraction here. So let's take a look at this problem. So integral of x minus 2x to the third divided by x to the fourth minus x to the second power dx. So what we want to know is if the denominator, once you find the differentiation of that, will give you the top expression. So let's go for that, okay? So we come in here and then we say, if we take x to the fourth minus x to the second power, and then we find the derivative of that. That will give us what? That will give us 4x to the third minus 2x. The question is that the same thing as the one that we have on the top there? Not quite. But is there anything that we can do that will make it like that? Yes. So that means what? We can factor this one by 2. If we factor it by 2, what do we see? We have 2x to the third minus x. It looks almost the same thing except to what? The signs. So the signs are the opposite. This one is positive 2x 3. This one is negative x. When this one is negative 2x power 3, and then that one is positive x. So what can we do? We take negative sign out. So once we take negative sign out, so we end up with what? We end up with positive x minus 2x to the third, which is then the same thing as the one that we have at the numerator, correct? So once we have that, we are confident now that we have this format. So we can go for it. So if we're going for it, that means what? That means we have this one is equal to. So now we're going to rewrite the problem because at some point, there's something that is missing because this one is inside, but we have a negative 2 here. But we don't have a negative 2 here. So we got to make an adjustment. To make that adjustment, we're going to have to put this is equal to negative 1 over 2. Then we have the integral of negative 2 times x minus 2x to the third over x to the fourth minus x to the second dx. And then, ladies and gentlemen, see what we just did. If you take out negative 2 and then negative half, what happens? You have the original problem back. That's the reason why we're doing it. And then the negative 2, we got it from here. But because we have the negative 2 there, we have to use the opposite so that we can cancel it. That's the reason why we're doing it, okay? So we're taking our time now to understand. Once we understand, now we can run, okay? So let's go. So this one is then equal to what? So this one is then is equal to, so now we're confident that we can do this. So now we can do u, so we can set up the bottom piece equals to u, right? So u equals to what? So u equals to x to the fourth minus x to the second. Now we can find the derivative of that. So is du over dx equals to what? So we're trying to find the derivative of u with respect to x. So that would give us what? That would give us then, so that means we're finding the derivative of that. That is 4x to the third minus 2x. We did it, earlier. So once we get this, so now we can derive dx out of it. So we can derive dx out of it. So that is dx equals to du over 4x to the third minus 2x. Okay? So once we get that now, we can take this now and then say, okay, so we're coming back here, and then we say this then is equal to, all right? So we see how our negative 1 over 2, we keep that. Integral of what? So integral of, so we have negative 2, parentheses x minus 2, x to the third, over, we have, now x to the fourth minus x to the second is what? Is u. We set it up to be u. And then dx is what? Dx now is equal to, so it's times du over 4x to the third minus 2x. See what's happening? So we're replacing what we have here into our problem. That's all we did. We didn't do anything else. So negative 1 over 2, integral of what? We keep this one because we didn't have any representation for it. So x to the fourth minus x to the second is u. So we have the u at the bottom here. And then dx is what? Dx is equal to du over 4x to the third minus 2x. Are we good? All right, so let's go. So we keep going. So this one is equal to what? So this one is equal to negative half. Okay, so because that's negative half, so what can we do here? We can simplify stuff. Is there anything that we can simplify? Yes, because negative 2 times x minus 2x to the third power is just the same thing as having negative 2x plus 4x to the third power, right? Because if you multiply the negative 2 here, so you're going to get this back. This, we can cross them out. So we end up with negative half integral of what? Of 1 over u times du. And what's the integral of 1 over u? We already did it previously. So that is just the ln of absolute value of u. So this is equal to negative 1 over 2, okay, times ln of absolute value of u. Then we got to add c. We add c because, remember, this is an indefinite integral where we don't have a range to this one. Okay, so we don't know what the constant is. So we got to get going. So we then have what? We know that u is equal to what? This one here, x to the 4th power minus x to the 2nd power. So we're going to substitute. So again, these are part of why we call this process here integration by substitution. So this one and that part. So then we have negative 1 over 2 times ln of absolute value. Instead of having u, now we have x to the 4th power minus x to the 2nd power plus c. Okay? And then this one is equal to what? So all this can just be negative 1 over 2 times ln of x to the 4th power minus x to the 2nd power plus c. So it's either or is correct. So we have this. Okay, so ladies and gentlemen, we finished with this problem here. You see what we're doing? We're taking our time, going step by step. Then once we know it, now we can run. Okay? Thank you.